Okay guys, today we are looking at differentiation of parametric equations in Math N6. So when we talk of parametrics, you see that y is defined in terms of the parameter t, x is also defined in terms of that parameter. So our target is to calculate the second derivative at t equal to 1. So let's start. I'll have my y equal to 2t cubed. So I will differentiate y with respect to t. That gives me 6t squared. Then I also have my x equal to t squared. I will also differentiate x with respect to t. That will give me 2t. So from here, we can't get the second derivative without first of all getting the first. So therefore, I'll go to dy over dx. For parametric equations, this is how you get it. You take that your derivative of y with respect to t, you divide by your derivative of x with respect to t. So I'm taking this answer to divide by this answer. So that gives me 6t squared on 2t, which I'm always advising students that once you get here, try to simplify it so that when you go to the second derivative, your work doesn't look too bulky. So if I simplify this, 6 over 2 gives me a 3. T squared divided by t gives me 3t. So there I'm done with the first derivative. It's now time to go to the second. For the second derivative, as an N6 student, you don't need to bother too much because the formula for second derivative is the very last formula on page number 7 of your formula sheet. So it is given as the derivative with respect to t of the first derivative you have just done. Then you multiply that by dt dx. So if you go to your formula sheet, they'll be using theta in the place of t. So here we don't need theta because there is no theta there. So we can then go on and do our derivative. So I'll be differentiating. So this is where I was saying if you don't simplify your first derivative, you might struggle. So since I've simplified mine, I'll simply be differentiating 3t, then dt dx, I get it from dx dt. I just invert that one, so this will give me 1 over 2. So I don't need to differentiate that. So I will only be differentiating 3t with respect to t, which gives me 3, then times 1 over 2t. So you can see that our second derivative of that function is simply 3 on 2t. So what is left is to get your answer at t equal to 1. So at t equal to 1, my second derivative is simply 3 over 2 into 1, and that gives me 3 over 2. So guys, that's how easy it is to get the second derivative of parametric equations. So that was a very simple problem. Let's now try another one which I guess might be a little bit challenging. So we are doing the same thing. We have the function x being 4 sine theta, and we've got y being cos cube theta. We need the second derivative. I didn't capture it well. Is the second derivative with respect to x at theta equal to pi over 6. So the procedure is the same. So I'm going to differentiate x first with respect to the parameter dx d theta. Should give me 4 cos theta. Then I do the same thing with y. Now with y, you see it is cos cube theta. So to be on the safe side, so that you don't struggle with differentiation, once a trigonometric function is having a power like that, the best way to capture it is like this. So that way you've seen this function as a function of a function. So if I have to differentiate this with respect to theta, I start with the outer part. If I differentiate, the power 3 will come in front, then I'll get cos theta. I subtract 1 from the power, it becomes a 2. Then I go to the core function inside, I differentiate cos, it gives me negative sine theta. So that is how your derivative is supposed to be for it to be correct. So now that I've got a derivative of x and the derivative of y all with respect to the parameter, I can then go to dy over dx, which is taking the derivative of y with respect to the parameter. You divide by the derivative of x with respect to the parameter. The derivative of y is there, which is 3 cos theta, or that square multiplied by negative sine theta. Then the derivative of x was 4 cos theta. So this helps me to see that this item will take out that, so I'm left with negative 3 over 4 cos theta sine theta. So that's my first derivative. I can now move to the second, which will require me to go to page 7 of my formula sheet and search for this formula. So that is the formula for doing your second derivative in parametric equations. So that way, this tells us that we have to capture the first derivative here. And you see, I keep emphasizing that at this stage, always do your best to simplify your first derivative to the simplest form, because you will need to differentiate it again. If I left it like this, I might be needing the quotient rule and product rule together. But the way it is, I will not have to struggle a lot. So that is what I will differentiating. I will multiply this by the derivative by the x, which means it will be 1 on 4 cos theta. So what I need to do now is to differentiate this. And you can see it's a product. So I must use my product rule and call one item u, the other one will be v, so that when I'm differentiating, I'll get uv prime plus vu prime. And don't forget, we don't differentiate constant. So if I'm doing my derivative, I will write my negative 3 over 4 first. That's a constant, I don't need to differentiate that. Then I take my u is cos theta. V prime means I differentiate sine, it gives me another cos theta. Then followed by a positive sign, my v is sine theta. Then u prime means I differentiate cos, will give me negative. If I differentiate cos, I get negative sine theta. So I then multiply by 1 over 4 cos theta. So what you will see in the bracket is cos times cos is cos squared theta. Sine times minus sine is negative sine squared theta. Then multiplied by 1 on 4 cos theta. So that is where we are going. Then our final answer for the second derivative should be, if you know your trigonometry well, you will know that this is cos 2 theta. So we are simply getting negative 3 times 1. So it gives me negative 3 cos 2 theta in the numerator. Because I'm seeing negative 3 is at the numerator, 1 is at the numerator, cos 2 theta is at the numerator. Then denominator, I get 4 and 4, which is 16, then cos theta. So this one again, for N6 students, is formula number 5, page 1 of your formula sheet. So that is how I get my answer. So what is left is to get the answer at theta equal to pi over 6, which means you just substitute pi over 6 there. If I substitute pi over 6, I'll get negative 3, the cos of pi over 3, because I'll get 2 pi over 6, which is pi over 3. Then I divide by 16 cos pi over 6, since there is no 2 down there. Then I switch to my calculator to get my final answer. Don't forget that with trigonometry, always remember that your calculator is in radians, so that when you do your calculations, you don't get any mistakes. So I'm getting negative 3. Let me start by putting my fraction. Sorry, I get negative 3 cos pi on 3. So that is what I get. Then I will divide this by 16 cos pi on 6. So that way I've got my answer, which is negative 0,108. So the last part is just about you knowing how to manipulate your calculator. So guys, thank you very much